Hey everyone, ever think about, say, a vending machine? How it acts totally different based on whether you've actually put money in.
Oh, yeah, definitely.
No coins, you get nothing. Put your payment in, suddenly, the lights come on, you can pick stuff.
Exactly.
Well, that kind of shift in behavior based on its internal state, that's basically what we're diving into today. We're talking about the state design pattern in software.
That's right. We're looking at some notes here from 08 Design Pattern State. The whole idea is understanding how an object can fundamentally change what it does based on its internal condition.
And our mission really is just to get the essence of it, right? What is this pattern? How does it work? Why would you even use it? But keeping it high level, not getting lost in the weeds of code.
Precisely. Focus on the concept.
Okay, so the source says this pattern comes into play when an object's behavior really depends heavily on its state. It even draws a parallel to the strategy pattern.
It does, yeah.
But it flags a key difference in how that behavior change gets triggered. What's the core distinction there?
Well, it's interesting. Both patterns let you swap out behavior, essentially. But with the state pattern, the changes tend to bubble up from inside the object itself. It's reacting to internal events or transitions. Strategy, you could say, is more like something external, telling the object which strategy to use right now. State is more intrinsic. The object manages its own state transitions.
Okay. So internal change versus external direction. To make this concrete, the source uses a really good example. A travel agency's booking system.
Ah, yes, the reservation example. That's a classic.
Right. A reservation can be like unpaid, then it becomes paid, and finally completed. You can instantly see how a reservation object would act differently in each stage.
Totally. If it's unpaid, maybe you can still tweak the dates, add a bag, stuff like that.
Yeah.
Obviously, you need the option to pay.
Sure.
But once it hits that paid state, maybe changing dates gets restricted or costs extra. But now maybe you can generate your boarding pass or check-in.
Right. New actions become available.
And then complete it. Maybe after the trip, you can only view the booking details, perhaps leave a review. The point is, the underlying reservation is the same object, but its current state dictates everything it can do.
So how's this actually built? The source mentions three main parts: state, concrete state, and context. Can you break those down using our booking example?
Sure. So think of state as like a blueprint, an interface, maybe an abstract class in code terms. It defines all the possible actions like pay, cancel, modify.
Then you have options.
Exactly. Then you have the concrete state classes. These are the actual states: unpaid state, paid state, completed state. Each one implements that state blueprint, but crucially defines what actually happens for each action in that specific state.
Okay, so pay in the unpaid state does the payment processing, but pay in the paid state might just do nothing or throw an error.
Precisely. And the last piece is the context. That's our main object, the reservation itself. It holds a reference to its current concrete state object, maybe unpaid state right now.
Oh.
And when someone tries to perform an action on the reservation, say, modify, the reservation object doesn't handle it directly. It just says, hey, current state, you handle this. It delegates the call.
Got it. So the reservation knows its state, and the state object does the actual work relevant to that state. Now, the source really highlighted something. The state changes often happen inside the state classes themselves.
Yes, that's a key differentiator from strategy again.
How so? And why does that matter?
Well, in the state pattern, often an action within a state will trigger the transition to the next state. So inside the unpaid state, when the pay method successfully processes the payment, that method itself might tell the main reservation, the context, to change its current state to the paid state.
So the transition logic is encapsulated within the state.
Exactly. It keeps that logic neatly packaged with the state it belongs to. You don't have this big, complex decision block sitting in the main reservation object trying to figure out transitions. It's much cleaner.
That does sound way more organized than, a massive if-else block checking the state constantly.
Oh, absolutely.
And the source points out, naturally, this is used a lot for things like reservations, orders, workflows, anything with distinct stages. The big win is avoiding those monster conditional statements. Why is ditching if-else or switch such a big deal here?
Well, think about maintenance. Imagine adding a new state, maybe pending confirmation. With if-else, you'd have to go back and modify that huge block, adding another condition, checking interactions. It gets messy fast, and it's easy to break something.
Right, error-prone.
Very. With the state pattern, you often just add a new concrete state class, implement the required behavior, and then update the transition logic in the state that lead into it. It's much more modular and less risky. Easier to test, too, since each state's logic is self-contained.
Makes sense. Cleaner, easier to change, easier to test. And it connects to other behavioral patterns like strategy, which we touched on.
Indeed. It's part of that family of patterns focused on how objects interact and distribute responsibility.
Okay, so wrapping up. The state pattern is basically a clean, object-oriented way to let an object change its behavior when its internal state changes. The travel booking example, unpaid, paid, completed, really shows it in action. One object behaving very differently based on where it is in its life cycle.
Precisely. It handles complexity by distributing state-specific behavior into separate objects.
So a final thought for our listeners to chew on. Can you think of other things in the real world or even other software systems that clearly operate based on distinct states? Maybe like a traffic light, or even your phone going from locked to unlocked or silent to ringing.
Good examples.
How might thinking about the state pattern help understand how those systems manage their behavior and transitions? Something to ponder.